Okay, so we are going to try this again, guys. This time I'm not going to try to use Teams to go through the whole thing because it just wasn't working for us yesterday and I don't want to run into that problem. But I do want to make sure that you guys know how to simplify these exponential expressions, okay? I found this flow chart, which it's a slightly different order in the way that I usually do things, but I think it's going to be very helpful for you. So what I've done is I've uploaded this flowchart separately into the module under today's date, where you can pull it up and that can help you kind of navigate through the problems that you have to do on your own. So I'm going to walk through it real quick. First thing we do is, do you have any powers being raised to powers? If you do, then you would go ahead and take care of that by multiplying each of the inner exponents by the outer exponent. If not, then you would move straight to negatives. Do you have any negative exponents? If yes, you go ahead and simplify by turning them to positive ones, which of course is flipping that reciprocal and flipping and making the numerator the denominator and denominator the numerator. If you don't, then you would go ahead and see, do you have any like bases on the same side of the fraction bar? That means if they're either both of them on top, two bases, or two bases on the bottom. If you do, then you go ahead and simplify by adding their exponents. That's the product rule. If not, then you would check, do you have any like bases on the opposite side of your fraction bar? If you do, then you go ahead and simplify by subtracting your exponents, and which is your quotient rule. If not, then it says you're done. I am going to add just one thing in, is that we're always going to take care of any zero exponents first. Okay, so just remember that. That's not in your flow chart, and it's not going to be in your flow chart, but I'm going to go ahead and write it in mine. We would take care of our zero exponents first. All right, so let's get started. You've already done some of these, so I'm going to go through the first few pretty quickly. If you don't already have them on your copy of your paper, then you need to make sure you fill those in. So we're going to go through that flow chart here. We do not have a power being raised to another power here. We do not have any negative exponents, but we do have two exponential expressions with the same base on the same side of the fraction bar, because you would think that there's like an invisible fraction bar here with the one underneath. So they're on the same side. This is just our product rule, which means we would need to keep our base here, and we would just add those exponents. 7 plus 5 equals m to the 12th power, and that's your simplified expression for number one. That one is pretty basic. For number two, we're going to start through that flow chart again. We don't have a power being raised up to another power, and we don't have any negative exponents. But we do need to go ahead and break apart what's happening within each of these expressions. So I'm going to go ahead and say, okay, that's 4 times w to the third times x to the 7th. And remember, these parentheses squished together means this expression is being multiplied times this expression. So all of this is being multiplied times w squared times x to the 5th power. We do have same bases on the same side of our fraction bar, because remember, if there's not a fraction split up, it would be like this whole thing is the numerator with a 1 underneath. So technically they're on the same side of the fraction bar. And we're going to go ahead and simplify those using our product rule. Our product rule says that if we have the same bases being multiplied together, we're going to keep the base and we're going to add the exponents. So we can only do same bases here. Our 4 does not have another coefficient to be multiplied with, so our 4 would just get dropped down. We have a w on this side and a w on this side, which means we would have to keep our base, add those exponents. 3 plus 2 is 5. We have x here and we have an x here that are being multiplied together. So we use the product rule there, which tells us we need to keep our base and we need to add those exponents. 7 plus 5 is 12. The last step is always going to be for you all just to squish it all back together. So our simplified exponential expression here is 4w to the 5th and then x to the 12th. All right, so now we're going to look at number 3. Here we do have a power. We have powers being raised up to another power. Anytime you have parentheses, a big set of parentheses, and you have one number on the outside of those parentheses, that means you have the power rule happening. We still have to separate out everything that's happening within this expression. So that's 3 times j to the 3rd times k to the 4th, and then all that's being raised up to the 2nd power. So remember, if you have just a number or a variable that doesn't have an exponent visible, there is an invisible one there, and we have to take that into account. And we're going to, with the power rule, it says that we keep our base and we would multiply our exponents. So 3 to the 1st raised up to the 2nd power would be 3, and then 1 times 2 is 2, so 3 to the 2nd power there. And then that is being multiplied times j to the 3rd, which is also raised up to the 2nd power. Our power rule says keep your base and then multiply those exponents. 3 times 2 is 6, so we would have j to the 6th power there. We also have k to the 4th being multiplied or being raised up to the 2nd power, which means we need to keep our base. Multiply those exponents. 4 times 2 is 8. And if we ever have a coefficient, like a number that's actually raised up to the exponent when we're doing this, that means we need to go ahead and take out and actually evaluate that exponent, which means we have to figure out if this means 3 being multiplied 2 times, we have to figure out what is 3 times 3. 3 times 3 is 9, so we would break that down to a 9. And then everything else just gets squished beside that 9 when we simplify. So it would be 9, j to the 6th, and then k to the 8th. There's your simplified expression for number 3. For number 4, okay, we're going to check, do we have any expressions being raised up to another exponent? That's what's happening right here. We have the big set of parentheses, and we have a little 3 on the outside. Our flow chart says that we have to take care of any powers being raised up to another power first, and we're going to do that by multiplying all the exponents. We still have to break this apart so we can really see what's happening. So that's 2 times x squared times y times z. That's all being raised up to the 3rd power. And then that expression actually is being multiplied times x to the 3rd times z to the 5th. Everything else that's going on in the expression, we got to still make sure we bring it down so we don't lose it in the process. We have a number without an exponent here, which means there's an invisible exponent of 1. We have 2 variables without exponents, so they also have invisible exponents of 1. Our power rule says that if we have powers being raised up to a power, then we keep the base and multiply the exponents. 2 to the 1st raised up to the 3rd power would be 2 to the 3rd power, because 1 times 3 is 3. That's being multiplied times x squared raised up to the 3rd power, which is going to be same base x. 2 times 3 is 6. We have y to the 1st being raised up to the 3rd power, so that would be y to the 3rd, because 1 times 3 is 3. And then we have z to the 1st raised up to the 3rd power is going to be z to the 3rd, because again 1 times 3 is 3. And now we've done the power rule, so we check what's going on with the rest of our expression. Our flow chart says next, do we have any negative exponents? We don't have any negative exponents there to worry about. So we would go to the next part, which is, do we have any same bases on the same side of the fraction bar? Remember, if there's not a fraction visible, there technically is an invisible 1 underneath all of that. So all of this would be on the same side of the fraction bar. If it's on the same side of the fraction bar, it says simplify the same bases by adding their exponents. You can only do the same bases. We don't have another coefficient here to multiply with, so we're going to just drop down that 2 to the third and worry about it later. We do have multiple x's that are being multiplied together. We have x to the 6th here times x to the third. So we're going to keep that base, and we're going to add the exponents. If they're on the same side, we add the exponents. We have 6 plus 3, that's x to the 9th power. We do not have another y to multiply with a different y, so we're going to just drop that down, y to the third still. But we do have two z's being multiplied together, one here, one here. So we keep our base, and we add those exponents. 3 plus 5 is 8. So now all we have to do is squish them together, except we have a number with an exponent, which means we need to evaluate it. 2 to the third means we have 2 being multiplied times itself 3 times. So that's 2 times 2 times 2. 2 times 2 times 2 is 8, because 2 times 2 is 4. 4 times 2 is 8. So we would have 8 as our coefficient in our simplified expression. All your other variables just get dropped down. 8, x to the 9th, y to the third, z to the 8th is your simplified expression there. All right, moving right along, we're moving on to number 5. We have a to the 5th, b to the 6th, c to the 15th divided by a to the 5th, b squared c. Okay, so what we're doing is we're checking our flow chart. Do we have any power? Number one, we don't have any zero exponents, so we don't have to worry about that. Do we have any powers being raised up to another power? Here we do not have a big set of parentheses with a small number, so no powers being raised to a power. Do we have negative exponents? We do not have any negative exponents to take care of. Do we have any like bases on the same side of the fraction bar? We don't have that. We don't have an a on the same side of the fraction bar, b on the same side, c on the same side. Same thing on this side of the fraction bar. There's not any like bases on the same side, so we don't have to worry about the product rule here either. So we check, do we have like bases on the opposite side of the fraction bar? And we do. We have a's across the fraction bar, we have b's across the fraction bar, and we have c's across the fraction bar. So that's what we're going to do. That's our quotient rule, and it tells us we're going to end up keeping our base and subtracting the exponents that have same bases. First, though, we've got to break it apart. We have a to the 5th, b to the 6th, c to the 15th. And that's being divided by a to the 5th, b to the 2nd, and times c. Remember, if we have a variable without an exponent, that means there's an invisible exponent of 1. So our quotient rule says that we're going to keep our base and subtract our exponents. So that would be a, and then 5 minus 5 is a to the 0 power, and we'll come back and take care of that in a moment. We have b to the 6th divided by b squared, which means we're going to keep that base, subtract those exponents. 6 minus 2 is 4. We have c to the 15th power divided by c to the 1st, keep our base, and then subtract the exponents. 15 minus 1 is 14. Anytime we see something raised up to the 0 power, we need to go ahead and take care of that. So what we're going to do is just going to turn it to a 1, because anything raised up to the 0 power equals 1 there. And then we still have b to the 4th times c to the 14th. All that's left is to squish it together. Because this is a 1, we don't even need to list it. That's always how the ones kind of work in algebra. You don't actually need to see the 1 there. It's understood that if there's no coefficient in front of our expression, that there automatically is a 1 there. So all we would need to be able to do is just squish these other two back together, and that becomes b to the 4th, c to the 14th power. All right, let's see, this is the end of the first video, okay? So there's gonna be a second video in order to get all of this down for you guys. All right, so this is video number 1.